Metatraders, Rich here. In this video we'll be looking at the iteration process, which is the next step in the system compilation process that we are using in the preparation of our portfolios. So in part 2 of this instructional video series we looked at the optimization process, and now part 3 follows on from this work, which uses the iterator to refer to the results of our optimization run and then iterate those results to produce an outcome at a system level and a per market level that looks at the best risk-adjusted returns that can be achieved through that suite of systems it defines from that entire optimization process. So to get this running, we refer back to the end stages of our optimization process, where we created 3 files in the back end of our Metatrader 4 installation. If you want to understand what these files are, just refer to part 2 of this instructional video series. So now, once the optimization process has been complete, we are now ready to move on to the iteration process. So the first thing we need to do is we need to open up our data folder again. I'll just get to where the original DON file was. And we need to go to the MQL4 directory here, and we double click on it, and we need to go to the files location underneath the MQL4 directory. You'll see there are currently a number of files in there already, but what we then want to do is we want to drag and drop the Donkian subdirectory from our tester subdirectory into the MQL4 subdirectory. To do that, we drag and drop the series into this new location. This is where the iterator is looking for its results. It doesn't look to where the optimizer looks for its results. There are 2 separate locations. So that's the first step you need to do. Once that is done, you're ready then to set up the iteration process. So the next step is to open up a chart in the chart window. So in this case, for this iteration process, we are conducting an iteration on Euro USD. So we turn off the strategy tester here, as we don't need to use this for the iteration process, and we open up a chart of Euro USD. Now what we want to do is use that template which you've received from your download zip file called the black iterator template. You'll see it in your list of templates. When you click on the chart with the right mouse button, refer down to template and then select black iterator. That then presents a chart in a method that the iterator uses. We need the black background because the information presented by the iterator is in text, and the black background helps show that text visually. Now it doesn't matter what time frame we set this template on with Euro USD, as the iterator works independently of this time frame, but just for good measure I tend to set it on the D1 time frame anyway. Then what we do is we refer to iterator, which in this case is the DON iterator 20025. We'll open that up, and the first, as we drag it onto, we could either drag it onto the chart or double click it to open it up. When we step through it, it's pretty straightforward. In the common settings, just to ensure that you've set it up in this manner with enable alerts and allow live trading, allow DLL imports, and allow import of external experts. That's for the common work tab. Now we go to the inputs tab. The first thing we need to do in the inputs tab is apply the password that is provided to our forum members on our forum. Then we need to look at the maximum strategies included in pool. Now, what this does, as previously mentioned in our optimization series, we iterated over 40-odd thousand different possible permutations with our optimization. Now what we want to do is restrict that number from 40,000 or so down to 500 of the best performing profitable results. So in this case, our initial cull is to look at the top 500 in terms of their profit result over that 20-year period. So we're using a maximum here of 500. We can use smaller levels if we require, but for our testing purposes we think 500 is sufficient to at least encompass overall the best performing strategies with positive expectancy, and from within that smaller section of outcomes we then undertake the iteration process. So our first sort is applying a 500 selection criteria for the top 500 of the entire optimization run. The next step is how many iterations you wish to do. So to explain what this does, of that selection of 500 strategies, there could be any possible combination of strategies within that entire suite of 500 iterations that produce the best risk-adjusted return at the overall portfolio level. It might comprise 10 strategies, 20 strategies, 30 strategies, or whatever, to produce the best risk-adjusted return. With risk-adjusted return for our trend-following models, we prefer the use of the MAR ratio, which is a relationship between the compound annual growth rate over the entire time series and the maximum drawdown over that entire time series. The relationship between that is a risk-adjusted return referred to as the MAR ratio. We prefer this to other risk-adjusted measures such as the Sharpe or Sortino measure, as those measures are more applicable to convergent models or mean reverting models, which are looking for a very nice straight linear equity curve at the individual strategy level. In our trend-following models, there is inherent volatility within those models themselves, expressed by very large step-ups and then periods of stagnation. So when applying measures such as Sharpe and Sortino, they don't properly reflect what we wish to achieve with our outcome of our particular models. Our models are wealth building models as opposed to cash flow generation models. So we recognise they don't have a nice linear straight ascent to the heavens, but the best risk-adjusted return we can use for these particular models is the MAR ratio. That's why we prefer it. So the first thing, with the number of iterations, at the moment it's set to 10 million. So within the 500 selection, it'll run 10 million iterations to identify the best combination of strategies from a risk-adjusted return relationship. In this case, that's too low, 10 million, so we have used up to 100 million, but what we find is at around about the 10 million level, there is a fall-off in the number of combinations selected, so the process beyond 10 million iterations becomes slower in determining better risk-adjusted combinations of strategies. So we set this to a level of 20 million just to assist our speed of processing, as opposed to say 100 million, which might take 5 or 6 hours. 20 million might take 1 hour or 2 hours to run. And the marginal improvements between 20 million and 100 million aren't significant. With the minimum random and maximum random, these are the settings you apply to say of the selection within your 20 million iterations, we want between 1 and 10 system strategies identified within this iteration process that produce the best risk-adjusted return. We could set this to any value, 1, 5, 20, 2, whatever we like. For this testing purpose, we're only looking at up to between 1 and 10 compiled strategies in combination at the Euro USD level, which produce the best risk-adjusted return applying our Donchian strategy. So we'll leave that at 1 and we'll leave the maximum at 10. Then with the starting balance we need to adjust this to $100,000, which is our initial deposit. So we'll just change that now. That's 10,000, so that's 100,000. Just got to check with these numbers. It's hard to see that you've got the right number of zeros in these models. So that's all we do, and now once we have entered the password, we then click the iteration process. So we have selected OK, and now the iterator commences. At the top of the screen here, the first step of the iteration process is this sort function where it is looking for the top 500 profitable returns from the entire 40-odd thousand iteration results from the optimization run. So as it's stepping through, you can see the numbers moving here. It's stepping through the iterations, and on the right hand side you'll see that currently we've got 132, 139, 149. This is 149 of the 500 series. So we wait until this number builds to 500, this last number here, and then you'll see the iteration process commence. So we're almost there now. We've now had 481 selected from the top 500. So when it reaches 500, we'll see the iteration process officially begin. So here we go. We're almost there now. We're now at 500 iterations. So now the iteration process has begun, and you'll see the information presented as the iteration process unfolds. See what it's currently found from the process. So initially when it starts, we have this last found indicator here which says at iteration 83,932 it found the last best combination. The number of steps it's taken to get to is stepped up 10 times since it commenced its iteration process in determining the best MAR relationship. The best MAR so far it has produced is 0.4269, and the number of strategies it's identified to produce that MAR relationship is 3 currently. So as this process steps through, if you remember, we set a number of strategies that it would select between 1 and 10, so somewhere between that number this entire process will find the best possible combination of strategies from a random iteration process conducted over 20 million iterations. So this actual process is a fairly lengthy one. It might, it might take a couple of hours. On faster PCs it's a lot faster. So this is a very slow PC, so it dawdles along. But that's all the information that we really need to present for this. But we'll now return at the end of the iteration process to show you the results. So we have now reached the end of the iteration process after about 3 or 4 hours, dependent on the processing power of your PC. Now at the end of the iteration process a message comes up, click to close the EA, you select OK, and then what you want to do is look at the additional files that have been generated by the iteration process. So to do this you go to File, Open Data Folder, and within that folder you will see in the MQL directory where we located our iteration folder of the DON series. When you open that up, you'll see that an additional 2 files have been created, one called EuroUSD Snapstrat Selected and one called EuroUSD Strategies. This is just a picture file which represents the end of the iteration process, the results of the process. So in this particular iteration of 20 million within a random number, within a range of between 1 and 10 strategies, it's actually selected 5 strategies which together produce the best MAR as a single system portfolio for Euro USD. In this case, the MAR will be 0.4736. Now, this is using the optimization results generated over a 20-year period. So in this instance, we have 5 strategies. We can see the parameter settings for the Donchian period, the ATR period, the stop loss multiplier, the trailing stop multiplier, and the break-even multiplier. And these are the particular settings for each of the individual 5 systems that together comprehensively create the best MAR for the portfolio. That's the picture file. Now the strategy file, this file here, is actually a CSV file of those same results, and we'll just have a quick look at them. So you see that we have 5 individual strategies here, and this is just a CSV file of that picture snapshot we just showed you earlier, showing the MAR of each of the individual strategies, which comprehensively then combine to form the overall MAR for the portfolio. This particular file here is an important file which is used in the next process, which is the trading process, where the trader refers to these settings to undertake trading in the backtest, demo or live environment. Now in this particular instance, it's going to therefore be looking for these 5 solutions to trade when we trade Euro USD with the portfolio strategy. We can change these figures manually if we want to, but considering this is the end of a very long iteration process and optimization process, these are the optimal settings for the 20-year period, but you certainly can change these values if you wish to, which means that when your trader refers to them, it'll use the manual values that you select. But we'll show you this at a later date. But these two are the important critical files created out of the iteration process. So now that we've finished the iteration process, we'll now, in the next video, refer to the tail end of the process, which is actually undertaking the backtest and the backtest walkthrough of the results selected from the iteration process, and at that point in time then the further exercise after that is going to the analytics, where we just validate that everything has worked correctly and the results aren't curve fit and are something that we're happy with. So thanks for watching this video, and stay tuned for the next video of our series.